video, we will discuss how to tackle limits and asymptotes. Here, overall, how to tackle limits. This is limits and asymptote. The asymptote. We discuss asymptote. Then note. Okay, point. No asymptote and vertical asymptote, horizontal asymptote. Okay. Let's say this is point A. Okay. X approaches A from right. A from right. Okay. And X approaches A from left. So when X approaches A from right, we can say that limit function fx as X approaches A from right equals something value. Say this is L. When X approaches A from left, limit fx as approaches A from left equals L, also L. And then when X approaches A from right, limit fx X approaches A from right is equal to infinity, positive. This is undefined. Positive infinity, we call this one undefined. Or when X approaches A from left, get the limit fx X approaches A from left is equal to positive infinity or undefined. Okay, sometimes when X approaches A from right, limit fx X approaches A from right, okay, the answer is negative infinity, also called undefined. Or when limit fx X approaches A from left is also undefined. Here is negative infinity. So all this one we can put in a box. Let's say put this case in one box. Okay, like this. And we can conclude here in one box. Okay. This is the case. Limit fx, let's say the function is like this, fx over gx, x approaches value from left or from right. And first thing, substitute when the problem is, say is 0, 0, and get 0 over 0. In this case, check when polynomial, okay, first case, polynomial, fx is equal to poly over polynomial dx is equal to poly. Okay, we need to reduce this function, okay, and cancelling by factorizing. Factorize, okay, and reduce to the simplest factor. And in the second case, when involve surd over poly or poly over surd, okay, you have to multiply with the conjugate. Multiply with the conjugate. Settle in the start when X approaches value, that is A. Approaches value A. Okay, so first thing is substitute, and if you get 0 over 0, this one called indeterminate form. For poly over poly, okay, fx poly over poly, you have to factorize and reduce to the simplest factor. Okay, when this function is surd over poly, or poly over cert, okay, you have to multiply by the 8. Okay, settle for when limit x approaches A from left or from right. Okay, as long as x approaches value, settle. And the second case, okay, when x tends to positive infinity or negative infinity. Okay, substitute limit fx x tends to negative infinity. Let's say this is equal L, and limit fx as x approaches positive infinity is equal to L. Okay, it's only two cases, either tends to negative infinity, x tends to negative infinity, or x tends to positive infinity. Okay, and with this case, okay, these two cases, and so I write in the box. These two cases, let's say limit fx over gx as x approaches infinity, positive or negative infinity, and first substitute value, and then if you get this one infinity over infinity, this is called indeterminate form. Okay, when indeterminate form, okay, you have two cases, same like this one, two cases. First, okay, first case is poly over poly, polynomial, fx polynomial, gx polynomial, polynomial over polynomial. You have to divide, okay, have to divide the highest power of denominator. Okay, the second case, when poly over cert or cert over poly, okay, you have to divide by modulus x. So for here, okay, for part poly, you have to divide by x. For part cert, okay, you have let's say check when x tends to negative infinity, okay, you have to divide by negative cert x squared. When x tends to positive infinity, you have to divide, okay, by positive cert x squared. So now for this case, when x tends to positive infinity or negative infinity, firstly you have to substitute directly, and you get that one is infinity over infinity, that one called indeterminate form, and check the function. When the function is poly over poly, you have to divide with the highest power of the denominator. When the function is poly over cert or cert over poly, you have to divide by modulus x. But here, okay, for modulus x can be defined as for poly function, you have to divide by x. And for cert function, you have already two cases. When x tends to negative infinity, the cert function you have to divide by negative cert x squared. When x tends to positive infinity, for such function, we have to divide by positive zx. Okay? Okay. So next step, that one is to find the limit. Okay? Then, how to find asymptote? And to find the asymptote, just check. Okay, just consider by checking. This is x value, a to the right and left, a from left. Okay, and this is y value, positive infinity. So when you get one value and one undefined, we can say that x is equal to a is a vertical asymptote. Okay, let's say here. This point is a from right. This is x value, and this is y value, positive infinity. One value and one undefined. We can say this one x is equal to a is a vertical asymptote. Okay, and then check this one. When x is equal to a from left, ay negative infinity undefined, so we can say x equals a is a vertical asymptote. Okay, same goes to here. When x a from right and y negative infinity, this is value, this is undefined, and conclude that x is equal to a is a vertical asymptote. Let's say here, this is value x, positive infinity, and L. This is value y is equal to L. So therefore, y is equal to L is a horizontal asymptote. Here, x is negative infinity, y is equal to L. This is y is equal to L. So y equals L is a horizontal asymptote. Let's say if you substitute here, this is a from left, L. This is not consist of undefined. This is value a for x, and y. This is just a point. Okay, same like this. A from right, L. A, x, y, just a point, not produce asymptote. Okay, when a, L, this is just one point. Okay, and when you get a positive infinity or infinity for x, positive or negative for x and y, this is also no asymptote. Okay, no asymptote. Okay, and if you get one infinity and one value, we can say that y is equal to L is a horizontal asymptote. Or when this one a and for y value is infinity, this one x equals a is a vertical asymptote. Okay, this is notes. Okay. This overview how to take the limits and asymptotes.